All right. So again, here, as I said, what I sent you by email had a typo in it. We have secant of theta. So we have theta. It's an angle. By assumption, it's acute. And not only that, secant of theta, okay, is 7/4. Secant of theta is 7/4 by assumption. We want to get all the other trig functions. So let's do that. All right, let me get the solution key up. Gotta stop sharing this. Good. Okay. All right. Oh, no, not there. There we are. Ah, here it is. So remember, secant of theta, right? Secant of theta we know is 1 over cosine of theta. So basically, we know that 1 over cosine of theta, that's equal to 7/4. And I did do this before. I think it was probably on the second day we did trig. What happened was, if you have 1 over cosine equal to 7/4, I mean, you could cross multiply and all that, but really, if you invert both sides, you get cosine of theta is 4/7. Cosine of theta now becomes 4 divided by 7. So that's what we get here. So really what we have then is cosine of theta, which is 4/7. Now, just like in the lecture notes, I don't think today, but last time, when you have this and you want to get the other trig functions, you want to draw a right triangle, okay, where cosine of theta is 4/7. You know, we have this triangle. This is a little bit more general, right? And cosine of theta we know is adjacent over hypotenuse. So we can get a right triangle where this happens if we make the adjacent side of length 4 and the hypotenuse of length 7. Okay, so again, for cosine of theta to be 4/7, we could take the adjacent side to be 4 and the hypotenuse to be 7. We just want a right triangle where this is true. And that's this triangle, as you can see. I know it doesn't look like this one. Bear with me, I had to redraw this. So we have this side is length 4, this side is length 7, but we don't know the length of this side, OPP, the opposite side. How can we get that? Pythagoreans theorem. Okay? Pythagoreans theorem. Namely, by Pythagoreans theorem, right? We have, here we go. There we go. We have 4 squared plus OPP squared must equal to 7 squared. Right? Pythagoreans theorem. And that's what we have here. 4, well, okay, so I wrote it like this, but it's really the same idea. OPP squared plus 4 squared is 7 squared. You know, you can add in any order you want. Okay. Now, right, we can use this to solve for OPP. So 4 squared we know is 16. 7 squared we know is 49. Subtract 16 from both sides, right? We want to isolate the unknown. So we get OPP squared equals 33. Well, if OPP squared is 33, what's OPP going to be? The square roots, right? You take square roots. So that's what we get. That's the square root of 33. So this side OPP has length radical 30, square root of 33. And really then, that's like the hard part, because we can get the other trig functions. Sine of theta is opposite over hypotenuse. OPP over 7. And we found OPP, it's radical 33. Sine of theta is radical 33 divided by 7. Cosecant of theta, remember, is 1 over sine. And so basically you flip sign and get 7 over radical 33. Cosine and secant we know already. Tangent of theta, that's opposite divided by adjacent. Opposite over adjacent. So it's OPP over 4. What's OPP? That's radical 33. So radical 33 over 4. Cotangent of theta, right? You flip it, you invert tangent, and you get this. You flip tangent, and you get this. All right, so that's the worksheet. Are there any questions on this? All right. Okay, let me start at least the next section I want to do, which is chapter P, section 5. Not going to get very far, but that's okay. This thing, yeah, here it goes. Okay, a little. Oh, come on. Here we go. All right. Okay, so here in section P5, we're actually going to look at rational expressions. Right? And basically, those are going to be kind of like the integers in that the way you get rational numbers, right? You take integers and divide them. It's the same thing with rational expressions. So essentially, we'll see what a rational expression is. I mean, I guess I just told you what it is. We'll see also how to multiply and divide them and add and subtract them. It's actually the same rules as when you're working with fractions. Same exact rules. You add and subtract fractions, you need a common denominator. Same thing with this. So it's a slight generalization. So now we're actually going to have to stop. We're out of time. So let me stop here.